My name is Ira Kohler.
I'm Yoel Ducey.
And I'm Milan Tammy.
And we did a science research experiment about the effects of caffeine on high school students' reaction time, blood pressure, and heart rate. We hypothesized that ingesting 65 milligrams of caffeine would lower the reaction time, as well as increase the heart rate and the blood pressure. So what we did, we gathered a group of participants. We got parental permission, and then every single time they came in, we either gave them caffeinated coffee or decaffeinated coffee. We had 2 trials per person. They would drink the coffee after we measured their blood pressure and heart rate. They would drink it, they would wait 30 minutes, and then after the 30 minutes are out, we would take their blood pressure and heart rate again, and they would play reaction time.
So to be able to accurately and efficiently conduct our experiments, we used our knowledge from all of our previous science classes and our engineering, and we were able to construct a reaction time game that we constructed in the building.
We had to do some research on how the circulatory system and the nervous system works to actually create the effects that caffeine has. So we found that caffeine is like a vasoconstrictor, so it contracts the blood vessels, so that's what makes your pulse increase and your blood pressure increase. And then we found how it interacts with nerve receptors to keep you awake. So we did have to do some extra biology research.
And we were able to collect all the data, and we were able to interpret it. We noticed that the reaction time on average with caffeine was lower, and we found that for the blood pressure that it was higher when the students consumed caffeine as to the decaffeinated.
Yeah, so as you can see here, the red is the decaf and then the blue is the caffeine. So each time the blue, or almost each time, the blue is going to be a little bit less than the red. And so we did a matched pairs t-test to see how significant our results were for this, and we obtained a value of 0.0405. And as long as the value is above 0.05, then it's considered a significant value. And here you can see with the changes in pulse, there's some up, some down. It's really varied, so we couldn't find anything significant there. Basically, after people had decaf coffee, for some reason their blood pressure went down. So, we had a few reasons for why some of these results we obtained were insignificant and why some of them were significant.
Can you tell me a little bit more about your reaction time game and why you built one?
We didn't want anyone to have any advantage from before, so we built our own, and we were able to do all the coding, do all the wiring, and we knew everything about it. We knew how it operated. We wrote the letters to IRB, which is the Internal Review Board. So in order to actually perform tests using drugs, which is what caffeine is considered, we had to ask permission from the principal of the school, the nurse in the school, and the head of the science department, Mr. Itzquitz. So we got all of that. We sent out a letter to the student body if they were able to actually participate in our experiment. We sent permission form to all students that were interested because we needed parental consent. Then we also had our initial results, like our background research. That's what helped us form our hypothesis. And then
Is that like a literature review that you had done?
Through a PhD level research papers to come up with a background knowledge and understanding of the topic to help us conduct the experiment. And another important thing that we made sure to do correctly was if the students came in and they knew which kind of coffee they were drinking, it would have been very bad because of the placebo effect.
What were some of the obstacles you faced?
Well, one obstacle we faced was just getting permission to conduct the experiment.
When we actually got permission from people, we had to work around their schedules because a lot of people, we were taking away their free periods for them to come and help us.
And then also, we did take a survey of what the participants ate and how much they slept, but of course we can't control for those factors exactly, so that could also cause some differences in heart rate and blood pressure. And yeah, so I think for the future, if we were to repeat this experiment, we would definitely have the participants rest before we actually tested their blood pressure and heart rate, and we would probably try to control for more factors like amount of sleep and what the participants actually ate.
What is your big takeaway from having participated in a full year of scientific research?
In the beginning of the year, we were mainly focusing on understanding how to read and interpret the PhD level papers, which is something that we've never done before, how to find a topic that interests us, how to actually go through it with some help from Ms. Lorber. At the beginning, it's like overwhelming, you don't know anything, but then as you go through it 3, 4, 5 times, you gather understanding.
I think I really gained like a greater appreciation of research. You know, sometimes you imagine scientists in like sort of an abstract way, like they're just sort of in their lab conducting experiments, but like it's really a difficult process, and you need a lot of knowledge, not just in science, but like for example, you know, we had to ask Mr. Levine to help us with some of the statistics stuff, because you know, you have to know, were your results significant, and you can't just do that by looking at the graph necessarily. So I think like really the broad knowledge that you need for research is really something very impressive.